Okay, the purpose of this video is to show you how to calculate sums of squares from SPSS output from having the variance in SPSS. And we do that so we could then calculate the sample standard deviation and the z-score for a single score in a sample, which uses sample standard deviation rather than the estimated population standard deviation, which is what SPSS outputs. So I'm going to share my screen. Okay, so let's work with GPA. This is from our class data set. So suppose I ask you to use the variance that SPSS outputs to solve for the sums of squares, so the total sum of all the deviations squared for the variable GPA. First, you need to get the variance. So select Analyze, Descriptive Statistics, Descriptives, right? You can right click and put display variable name so you can see GPA, move it to the variables field, click options and select variance. Continue, okay. Okay, let me show you the output window. All right. So here's the output window. Let me get a pen. Okay. Here we have the variance, okay. We're looking at this output down here. All this is old stuff, right? Here's the variance right here. All right, this is a pretty small variance for GPA, right? So we want to use this value to solve for the sums of squares, okay, which sums of squares just refers to the sum, that's sigma, of the square deviation. So x minus, sorry for the messiness, mean of x squared, okay? Now, we know that the variance, okay, this is the estimated population variance, right? Right, equals the sums of squares. So last time I'm going to write this out with this sloppy notation here. Divided by n minus 1. So we want to solve for this value here, right? We want to solve for that value there. So we have the variance is 0.338 equals sums of squares, which is our unknown, right? Over n minus 1. So n, okay, go down here. N is 90, right? 90. Okay. So 90 minus 1 goes down here. So 90 minus 1 is 89. All right. So far, so good. Now, in order to isolate sums of squares, we multiply both sides by 89. Okay. We get to cancel these 89s and we get out our calculator. So we get sums of squares equal, and we just have to multiply these values. So I'm going to use my calculator. I'm going to go 89 times 0.338 equals 30.082. There we go. That's how to find sums of squares. Later, you'll plug this again into the equation if you want to get the sample standard deviation. All right, so the sample standard deviation is going to equal the square root of the sums of squares. So this is 0.082 divided by n, which is 90. All right. So that will get you the sample standard deviation, which you could then use to calculate a z Z for a particular score in the sample.